hate speech refers to any expression that denigrates a person or group of persons based on their membership of a social category defined by attributes such as their race, their ethnicity, their gender, sexual orientation, religion, age, physical or mental disability, and other characteristics. Offensive speech, on the other hand, refers to any speech that causes someone to feel resentful, upset, or annoyed. In this tutorial, we're going to design a machine learning model that is going to automatically dictate whether there is a hate or offensive speech in a text. My name is Emre Goodluck, and I'll be leading you in this tutorial. Now, to carry out this task, this is a type of machine learning task that is under natural language processing. It's also a subcategory of artificial intelligence. To achieve a full machine learning task, we take some vital steps, such as we're going to take in this particular machine learning model. First, we're going to import the relevant libraries. So I've broken down these steps and have created empty cells with markdowns that can guide us in this. So the first thing we're going to do is to import relevant libraries. After that, we are going to import the data and do some data exploration. After which, we'll do preprocessing. That's to beat the data into shape such that our model will be able to be trained on it. And then we do the training, and finally we do the testing. Now, within each of these subcategories, you could see there are empty cells and there are markdowns that explains what is going to happen in each of the cells so that we'll be guided by this. This is just built for the purpose of guiding us so that we don't begin to wander away or get confused along the way. So how are we going to begin this task? Yes, we're going to use a couple of libraries for this purpose. So we will begin by importing pandas. Conventionally, we import pandas as PD. Then we'll import Numpy because at some point we're going to be using the convert the text to Numpy arrays. So we are importing Numpy as NP. That's also the standard convention. It doesn't mean you must stick to that. However, Pythonists usually prefer to stick to importing it with the alias NP. Now, from sklearn.features, that's feature extraction.text, we're going to import count vectorizer. And then from sklearn.model selection, we shall be importing the train test split. From same sklearn.tree, we shall import decision tree classifier. At this point, you will be able to recognize that that's the algorithm we're going to use. Now, from sklearn.metrics, we shall import accuracy score. Now, other libraries that will be required here includes NLTK. Then we shall also import regular expression RE, import NLTK.corpus, NLTK.corpus, import stop words. Sorry, this is from NLTK.corpus. So from NLTK.corpus, import stop words. And then we'll set stop words to English and set the stemma to English. So let's do that in a different cell. But before then, it will be ideal to run this cell and be sure that our importations has been done. Define stop words, stop word now, not words, and we set that to stop words dot word and say English. That's setting the language. The same way we say the stemma is equal to NLTK dot snowball, a snowball stemma, also set to English. Okay, so let's run this. That works fine. All right. Now, these are basically the libraries we'll be using for the purpose of building this machine learning model. Now, as we go on, you are going to understand the essence of each of these libraries. Basically, Pandas and Numpy helps you to import and manage the data, converting them to arrays, data frame, and all that. The Sklearn enables you to do your classification, while the NLTKs that you find here are responsible for majorly the pre-processing. Okay, so as we proceed, you'll see these things in action. Now, we are going to use a very common data set that you could download from Kaggle. I downloaded this from Kaggle, and it's actually a data set that contains hate speech and offensive languages. So let me quickly import it. I already downloaded it and stored it within the same folder as this notebook. Meanwhile, what we are using here is a notebook embedded in VS Code. So I do so because I would like to get the IntelliSense of VS Code, and the colors you are seeing, they enable me to be guided and be sure whether my codes are in order or not. While the notebook, of course, is usually the standard for machine learning models. So why we prefer to use notebooks so that we code in various cells and equally be able to add our markups, the markups you are seeing here that enables us to explain in the manner in which we are doing. So right now I want to import my data set. So I may decide to call this data underscore df, indicating that I'm referring to a data frame, and then I say PD, that's the pandas right now, dot read CSV, because the file is in CSV format. You could see that in Excel. So the file name train.csv. Okay, so I call the file name here, and that file comes in. I guess it's been imported. So let's quickly take a look at the data set. I'll create a new cell here and I type data underscore df dot head. So let's see what the data looks like. Control enter. So it's giving us the first 5 elements or rows in this data set. Here you have count, you have hate speech count, offensive language count, neither, then the class it is, and lastly you have the tweets. These are tweets. So as supposing I want to display up to 20 of these instead of 5. Okay, let's display 10 and run this again. Okay, so we have more of them. These are basically tweets, people's post on Twitter. Now for this, we have these numbers indicating the class, and here we have actually 0, 1 and 2. Now 0 stands for hate speech, 1 stands for offensive speech. So that's what this class here represents. So if you read through this tweet, you would see that. However, this is according to the annotation of the people who did the labeling for this data set. One, and if you are not very free with reading annoying text, I do not advise you go looking through these tweets because they are quite offensive and contain hate speech. In case it targets your own subgroup, spoil your day. So let me quickly run this again and show only just about the first 5 of these. Now, the next thing we want to do is to modify the heading of these data sets. We want to modify the heading so that we can refer to it as tweets and then um, convert the labels, convert those 1012 into recognizable labels that we can deal with. So how do we go about that? So we'll say the data frame, that's the label of the data frame now, should now be equal to class.map. And what are we mapping? We are saying that henceforth 0 should become hate speech. 0 should represent hate speech and 1 should represent offensive speech, while 2 should represent neither hate nor offensive speech. And then we will now change the data frame. So we'll now change the data frame to now entirely become, to just pick only the tweet and the label. The tweet and the labels. So let's see if this works. All right. Okay. So if this works now, let's see what the data frame is again. It look like dot head. Okay, so you could see that the other columns are gone. What you now have is just the tweets and their labels. So let me see if this can increase, if we see more of, okay, let's run that again. So offensive, there are a lot of offensive speeches here. Almost the beginning part of this is offensive. Let's change and see what the tail has. Offensive, non-offensive. Do we have any hate speech? Okay, hate speech, you are niggas. Sorry about that. But that's an offensive, that's a hate speech referring to a particular set of persons. So that's what the tail is like. Okay, now we'll go down to take another summary look at our data. Let's do the describe. Let's describe the data set and see. It's part of the exploration. It will enable us to still understand the nature of this data. I run that. You could see under the tweets, we have the count is 24,783 rows. That's exactly the same number for labels. Now, when you talk about being unique, we have all the rows are unique to themselves. There is no repeat. That's in terms of the tweets. However, the labels are classified only into 3. We have mentioned that already. So all this while we've been saying it's either it is offensive, it is hate speech, or it is not. So those are the 3 categories. And here is just showing us the topmost one and the frequency. Here is the frequency of this is 1, the frequency of this is okay. So that's just it. Now let's see the classifications that exist. In case you didn't see that clearly initially, you can look at the unique values in that label so that it will show us directly what we mean. Let's see. It's part of the exploration. Remember, we're just learning. So if you check the data frame again and look at labels, and you are now saying dot unique. So show us all the unique values in labels. Yes, it shows us that we have the no hate, no offense. We have offensive speech, we have hate speech. Okay, that has already been established. Now let's look at the distribution of each of these. To do so, we will need Seaborn. I don't remember importing Seaborn. Okay, we will need Seaborn. All right, let me just quickly import Seaborn where we are about taking this task. Okay, let's say import Seaborn because we want to plot a chart now as SNS. Okay, that has been imported. Okay, still trying to import. Okay, that has been imported. So now the next thing we want to do is to set the theme. Say SNS.setTheme. Let's leave it at the default. And then we will now do the plotting SNS dot. Let's use count plots. And what are we plotting? The data we are plotting is the data frame, whereas the only category we now want to show is the X category, and we want to say that you should use labels. You should use labels in doing so. So let's run this and see what it gives us. All right. Now this shows us the distribution. You could see that majority of the data sets are actually offensive speech. We have just less than 5,000 no hate or offensive speech, whereas we have less than this should be around say 2,000. Is it even up to 2,000? Let's say 1,008 hate speech, but the rest appears to be offensive speech. That's all right, but this shows us the what the data set is like. So after that, um, the next thing we want to note what these values are like. We say data frame dot head first. Let's look at the head. There is something I want us to note. There are a lot of mentions. Let's make this up to 10. The first 10 rows. Okay, yes. You could see there are a lot of mentions here. You can see at this, that's like at wherever you see this is actually user handles on Twitter. Okay. Now, and a lot of other characters that may not really contribute so much to the usefulness of our model. The tail, on the other hand, data. So never mind, we do a lot of explorations on our data because the better you understand your data, the better you can work with it. Okay, so here you could also see there are a lot of things that will unnecessarily interfere with our model training, which we are going to deal with in the pre-processing. Now, that's the essence of the pre-processing. Okay, so far what we've done is to import the data sets and then do some explorations, do some feature extractions like feature conversions and so on, so that our data set is looking like what we want to work with. So right now, we're going to do some further pre-processing in the form of working on the text to bring it down to what it should be. All right. So here in the pre-processing, what are we going to do? The pre-processing will involve cleaning this text. We're going to clean the text, removing the things we consider as unnecessary. So I am going to use different cells to achieve different things here. So the first thing is that we're going to write a function that will enable us to do the cleaning. So that function, we are going to call it clean underscore tweet. Of course, it's the tweet alone we are cleaning. And it will receive the tweet as text. And when it does so, the first thing we're going to do is to convert those texts to lowercase. Yes. So text is equal to the text that he brought in dot lower. Okay, so this converts to lowercase. Now, after that, the next thing we may want to do is to remove punctuation. So how do we remove punctuation? We say text is equal to the regular expression now, sub, this is R. So what do we use to indicate the punctuations? Wherever he finds any of these, he should replace it with nothing. And where is he supposed to be looking at? He should look at text. Okay, so let's see if that works. I believe it works. All right, the next thing is stop word removal. In natural language processing, there are terms that we use in English that helps us to fleshing up our sentences. However, they literally do not contribute so much to the eventual meaning of that sentence. Words like and, words like for, they do not really contribute so much to the meaning of the sentence. So when we are doing natural language processings of this kind, oftentimes we want to remove them. Whereas there are some natural language processing techniques that do not bother about removing them, like Hugging Face, for example, works very well with stop words, works with punctuations, works with all kinds of symbols because they even contribute to the meaning of the words there. But when we are doing NLTK kind of task, we often want to remove them so that we reduce distractions for our model while training it. So it's on that basis that we want to say that stop words should now be equal to set stop words dot words to English. Now, to filter out stop words, we would say text is equal to word for word in text dot split. We want to say that if word if the word is not in stop words, then it should be left, but if it is in stop words, it should be removed. It will be leaving only those words that are not in stop words. Now, the next thing is to do the stemming. So to do the stemming, let's say from NLTK dot stem, let's ask it to import porter stemmer. So the stemmer now is equal to the porter stemmer we just imported. So the latest version of our text should now be dot stem each word for word in text. So what are we returning from this? We are going to, from this function, we are returning, this is space dot join dot text, join text. Okay, let's see how that goes. All right. So meanwhile, what do we mean by stemming? Is either stemming or lemmatization. Now, what it basically does is that apart from tokenization that breaks words into, let's say pieces now, after breaking the words into pieces, what stemming does for you is to convert those words to their root words. It will convert them to their root words. So kind of some words, collection, collecting, they all come to the root word collect, right? So that's what stemming is like. And that's what we are attempting to do here. So now the next thing we want to do now is to call that function for it to perform its job on our data frame. So in the new cell, we say data underscore df, am I right? Yes. And on which column is going to do this on the tweet is equal to, that's the former tweet now, dot, it should apply the clean tweet function, and that's it. It will come perform its own task. So we might want to see what it returns. So let's quickly look at the head again. Let's look at the new tweet alone dot head. Okay, so let's see when this is applied. There seem to be some errors. Invoking series. Let's see. Stop words. Okay, I'll take a look at the errors. The error we have here says in line 1, and if you trace that line 1, it goes into the function. And right there in the function, it is looking at line 6. And at the end of the day, it says cannot access local variable stop words where it is not associated with a value. Now, going back to the code, I realized that the variable that is supposed to be assigned should have been stop words here. Now, when you correct this and try running this again, okay, there's still an error. This time around, the error is pointing at line 8 and it's talking about for words in text.split, if word not in stop words. So the stop words is also supposed to refer to here should be the variable now. So we had to use underscore to split it. So if I run this again now and run this, okay, run, at the end of the day, we'll see the head of the tweet. Let's see what it looks like. Okay, so what you have here, it has cleaned all those things we were seeing earlier. Let's see earlier than now. Look at what the head looks like. But if you check, there are capital letters here. If you check, there are these mentions. If you check, there are these punctuations, exclamation marks, and all that. So all those things have now gone. And looking at the same head, all you have is RT. Then you have so all the characters that are mentions, stop words, and punctuations have gone. They've all gone. So that's what the data set is like now. So let's create the NumPy array for the tweets and labels in preparation to run our model. Let me just delete this cell. In preparation to run our model, we say x is equal to np.array. Of course, is the data frame we're looking at, and x should be talking about the tweet, and literally the same code. So let me just copy it and paste for y. So I come back and change this to y, and I equally change this to labels. Okay, let's see whether that works. Okay, that has happened. So right now we need to convert the tweet into a matrix of token count. So say CV is equal to count vectorizer. Okay, that has been implemented, and now it's time to prepare for our training. So our data set is set for training. The first step we're going to take in the training is to fix the text, fit the text into the transformer so that it will transform. So how do we do that? We say x is equal to cv dot fit transform, and where should that happen? It should be on the x array. All right, has that been fit successfully? So we now split the data set into training and test data. By that, we are going to say x underscore train, x underscore test, y underscore train, y underscore test are all equal to train test split is going to have x, y, test size is we are defining the text size to be just 33% and the random state to be 42. Now let's see if that will be successful. All right, there's a split. So each of these values now has its own portion. X here fits into the X train, Y fits into the Y train, X test and Y test equally picks their various values. That's the output of this function. So it assigns it to these four variables. All right. Now, to initialize the algorithm, we'll say model is equal to decision tree classifier. And then let's fit in the data set by saying model dot fit. We have X train, we have Y train. Okay. Now the training takes effect and all right, of course, it's using decision tree classifier. Now, what next? Let's say Y predict, we want to predict Y is equal to model dot predict bracket opens X underscore test. Let's see that. Okay. All right, it's been able to predict now. Let's now see the outputs. Okay, before that, we check the accuracy, please, so that we can get the score for the accuracy of this. So we're going to be printing the accuracy. So the accuracy score, which we imported earlier, is going to take the value of Y test and check what Y predicts, how much Y predicts fits in, and is giving us 0.89 accuracy. That's a very good score. So let's quickly try to give it a text and see what will happen. So if you say I is equal to, let me test with I love you, which of course we know should neither be a hate or offensive. So let's see if there is no error, that should be able to give us a correct answer. So CV, so that we can transform that text to CV.transform, we are transforming I to array so that they will be in the same shape. I mean, the text we just entered will be transformed to look like the values we used in the model too. So model.predict, let's see what that gives us. It says this is neither no hate, no offense. Okay, let's try something else we may consider more hateful. Let's see what it gives us. It says it's an offensive speech. Fuck you, nigga. All right, generally that's an offensive speech. So when I try the example, fuck your ass, you see it's recorded as offensive. Now, this may not be perfect, owing to the fact that the data set as I see it is already screwed. We have more offensive speech here than we have hate speech or even neutral, what I may consider as neutral speech. So in most cases, it is quick to dictate the offensive speech. And also, due to the size of the data set, it might actually overfit to these data sets and not be able to generalize. You can look at the data sets, copy some of the examples and try them out here. But there are words that may not be anywhere at all in this data set. If you key them in here and test, you may not get the result you want. However, the steps we have just taken are steps that can be used to develop and train a machine learning model that can dictate hate and offensive speech and be able to predict a text and tell you whether they are hate, offensive or not. And this is where we'll be ending it for today. Remember, we began by telling us what hate speech is. And for us to do that, we first imported our libraries, relevant libraries for this model development. Then we did look at imported our data here. And then going through it, we tried to understand what the data looks like and eventually modified them to suit into the kind of algorithm we want to use to train our model. So as we are going through it, we're reshaping it until we got the shape we wanted. Eventually, we did the pre-processing, removed the items we do not want from within the data set. That's what we did here. Cleaned the data set, converted it to lowercase, removed stop words, removed punctuation, and then tokenized it at this point. This was done to split the words. So that's a kind of tokenization. After which we now did the stemming. After the stemming, we were able to join the words back together to form sentences. So we took another look at it here and we saw that it was good. Then we converted it to a NumPy array. We converted the tweets and the labels into a NumPy array. And then we got in our canned vectorizer. We brought in the model, fit these values into the model, the array into the model, then did the splitting of the entire data set into the training set, the test set. After that, we now initialized our algorithm, the decision tree classifier. Then we did the prediction and did our testing. We got an accuracy of, by the second test, I think I ran this a couple of times, but the first time we ran it, we got 0.89, and this time we're getting 0.87. If you keep running it, definitely you keep getting, because it does a kind of dynamic change in the splitting of the data sets and all that. And then even the training, it's a machine learning model. There's nothing constant about it. And at the end of the day, it was able to classify some text, a reasonable amount of them, as either offensive or hate speech, or neither offensive or hate speech. So thank you for your time. Thank you for learning with us. If you want to continue seeing more videos that look like this, that teaches you data science, teaches you machine learning model, how to build machine learning models, or how to do different artificial intelligence related tasks, you should subscribe to our channel. You should set your notification. You should keep in touch with us. If you also have jobs that our skill can help you do not fail to contact us. We'll be here for you. Thank you. Have a nice day.